All right, y'all got 1 week till your EOC next Thursday. So this time next week, instead of starting class, y'all be starting up your EOC. All right, so let's try that without Desmos. Go ahead and try and find the zeros for our quadratic function there. Typically on the EOC, you got at least one of those. -4 and a +1/3 is correct. All right, so when we're trying to find zeros, we got our x. On the top, we got a times c. So in this case, that's 3 times -4, so that's 12. We got our b on the bottom. We look for what would multiply to make our top number, add to make our bottom number. So in this case, we're looking at a +12 and a -1. Once we have those two numbers, we got one more step to it. We got to divide by our a coefficient. Our a coefficient in this case is 3. And we simplify. 12/3 simplifies to 4, or you can look at it as 4/1. The 1/3 doesn't simplify. What those are right there, as is, those are for factoring. Okay? So if we factored it, that would be where we have our parentheses. The denominator is the coefficient. So the -1/3, 3 is our coefficient, we got -1. For the 4, the reason I wrote it as 4/1, the 1 would be the coefficient, and it was a +4, so it's a +4. For the zeros, what you're doing is you're setting each factor equal to 0. Basically what you're doing is you're changing the signs on the numbers we got right here. So all we have to do for zeros is change the signs, so that becomes a +1/3 and a -4. Or like I said, we solve each one of these equal to 0, and you would get those same numbers. Okay? Any questions on that? Calculator active, even easier, as most. Crosses the x-axis. Now, that's what's going to give you that 0.3 reading, the decimal there. So if I have to solve this for x, what do I need to do first? Yeah, we got to get everything on the same side. All right, so we got to move the 40 over. Do that. Anytime you move something from one side to the other, you got to do the opposite. And you're basically doing it to both sides. We want it to cancel out from the side we're moving it away from. And we're not really just from that whole side in general. So that's going to give us x squared plus 3x minus 40. All right, and all that's going to be equal to 0. And since it's equal to 0, again, what you're looking for would be the zeros. So right back to our x. This one, a little easier. We don't have to worry about a coefficient. So we got negative 40, positive 3. Anytime your bottom number is bigger or bottom number is positive, that means your bigger number is going to be positive on the sides. Bottom number is negative, that means your bigger number is going to be negative. So in this case, I got positive 8, negative 5. I don't have to divide those by anything because I said the a coefficient was just 1. Zeros, once again, change the signs. So that means my zeros would be negative 8, positive 5. Everybody good with that? But if we ever get equations like that, get everything the same side first. Then you start worrying about trying to solve it. Okay? This one, definitely a calculator active kind of thing. The length of the line segment between those two ordered pairs. So go ahead and give me the length there. Between negative 4, negative 3, and 8, 13. I personally prefer the yellow calculators for these types of problems. They're quicker, I think, to use than Desmos, but Desmos does work for these as well. Who thinks I got it? Ella? 20 is correct. Length. Length is the same as distance. Looking for the distance between the 2 points. Whenever you're looking for distance on stuff with ordered pairs or coordinates, that's Pythagorean theorem. When you're doing Pythagorean theorem, we're taking the square root, trying to find hypotenuse. We use the change in y and the change in x as our legs. So the change in y from negative 3 to positive 13. That's the distance. So I got 16 squared. When we find hypotenuse, we're adding. Then I go from negative 4 to positive 8. That's a distance of 12. So if I do the square root of 16 squared plus 12 squared, that gives me 20. In this case, we get exactly 20. A lot of times, decimals problems every so often. Usually, if it says approximate like that, it will be a decimal, though. Any questions on that one? So now we got to find perimeter. So you get a lot of different kind of shapes. I've seen pentagons, I've seen octagons, I've seen hexagons. What's the seventh one? Septagon. I don't think I've seen a septagon, actually. I don't see why you couldn't see one, but... How many times do we have to do Pythagorean theorem on this one? Just twice, yeah. So that's the good part about this one. There are 4 diagonal sides, but 2 of them match each other. So find the perimeter. Typically, you want to go to like 2 decimal spots with your rounding. All right, Adrian, what you got? 22.32 is correct. Our diagonal sides, we got to make those a hypotenuse to find the distance. So if I make, whoops, I'll go right here. I've got 4 and 3 as my legs. That's going to make a distance of 5 right there. I do square root of 4 squared plus 3 squared. That makes that hypotenuse exactly 5 on each of those. So it worked out to a whole number. On this one here, I've got 1 and 3 as the legs. That one does not work out to a whole number. That's about 3.16. Have to round a little bit on that one. So we got about 3.16 again over there. And then on the straight side, you could just count the squares. Personally, I don't like counting the squares. I just go by the numbers. It went from -2 to +4. That's a distance of 6. I have noticed 8th graders make mistakes counting the squares. Something that's very easy. Y'all make a lot of mistakes with. Some of y'all actually do a lot better just looking at what the numbers are. It went from -2 to +4. So then we add those up. When we're adding them up, if you happen to draw on the picture like I did, just make sure you're adding up the correct numbers, the ones that are part of the perimeter. So that's the 6, the 3.16, the 5, and the 3.16. Oh, no, I forgot. What was it? 23.32? 22.32? Any questions on that one? Those ones usually aren't too bad. You just got to remember, use the Pythagorean theorem on those diagonals. Been doing pretty good with these, so hopefully we still are. Find the midpoint of those 2 points. All right, Jennifer, what you got? 10 sevens, correct. You're literally finding, like it says, midpoint, halfway, okay? It's the halfway point. What you're doing, you add the two together, divide it by 2. So add the two x values, 14 plus 6. So if I got 14 and 6, that's giving me 20. What I'm doing then is dividing by 2, that equals 10. That's my x value. For the y values, I got 11 and 3. So I got 11 plus 3, that's 14. Divided by 2, that's 7. Everybody good with that? Midpoint, like I said, that's literally like it sounds like. It's the point midway through or halfway through.